Yeah, one of the things that I really enjoy about working at Marlin is that, like Drew said, we get a cradle-to-grave product design experience. So in the very beginning, when the salesman talks to the customer, they'll get a list of design requirements and criteria. Usually once we look through it, we'll have a few more questions, so we'll go and sit down with the customers and the salesman, whether it's a face-to-face meeting or over the phone, and we try to flesh out all of the design criteria. A lot of times customers don't tell you everything about their system just because there's so much to their machine or their robot, and they'll tend to leave out critical details. And so it's our job to really probe for that. And over the years, you get used to looking for certain things. You understand what the critical areas of the design are. And so from there, once you have all the details that you think you need, then we take Autodesk Inventor and we make a solid model and create a drawing. We send it to the customer, and they'll go ahead and mark it all up. And we bounce the drawing back and forth until we can agree upon a design that works both for the customer and we can make for them quickly and efficiently in our factory. One of the challenges with that is always understanding the limitations of the machines that we have. And one of the nice things is that because the company invests so much back into our machinery, our capabilities are expanding every year, and we have more and more tools to accomplish the tasks that the customers are asking of us. So from there, once we have an agreed upon design, our engineers will take that design and we have to break it down and dimension everything completely. For sheet metal, you have to make flat patterns, so that way the factory is able to make every little component and assemble it completely. And everything has to be fully toleranced so that the final assembly comes together correctly. And also part of that step is creating a bill of materials so that our purchasing department can get all of the materials in time. After that, once the factory starts building, we do a first article inspection. So the first piece off the line, we get to go out and inspect, and then we also inspect a percentage of the lot after it's been completed. So you get that experience of you draw something one day for a customer, and then within a few more days or weeks, you get to actually see it out on the line, and then you get to see it ship at the end, which is a really rewarding experience. So like I said, I'm the lead engineer at Marlin. Some of the things that I wanted to cover, a little bit more in depth on what does Marlin make. You hear a lot about baskets, but we do more than baskets. And what is the job like at Marlin, as an engineer at least, from the engineer's perspective? How do we use CAD? And then maybe a few things that you could take away as far as tips and courses that I would recommend. So what does Marlin make? We have four main categories, really, at this point. The first would be wire products. These are things like baskets. I have a heat treating process, or I have a chemical cleaning process, and I can't just throw my parts into any old bin. I need them held in this orientation, and I need these surfaces exposed, and when they go through this robot, and they're going to interface with my machine in this way. So that's where a lot of our wire products fall. And wire is an appealing product for those kind of processes because it's round. Only that tangent surface is touching the wire, so you can really clean a lot of the surface area of the parts. And it also allows a lot of fluid flow through the parts holding container. We also have a 3-axis CNC router. We do a lot of internal fixturing and things like that, and I'll get into a little bit more detail on that. But mostly we're cutting plywood with that and MDF. We have our sheet metal fabrication, which is one of the newer areas that we're getting into. We have punching and press brakes, like you saw on a lot of Drew's slides, And laser cutting now is one of our newest machines, which really allows us to be very creative with our designs. And then the other machine that Drew showed on his slides, the 3-axis mill for machining, and like he said, there's a 4th-axis rotary in there, so we can do simultaneous 4-axis machining now. So getting into some specifics about the wire products, like I said, these are all types of cleaning or heat treating baskets or just parts handling. So that the bulk of what we do is actually in wire because we came from wire, but we're getting bigger and bigger in the sheet metal and machining areas. The router that I mentioned, we have a 3-axis CNC router, and one of the ways that we're always trying to get faster and better quality is by, when we got this machine, we can create all of our own fixtures in-house. We make them out of plywood because it cuts out very quickly, and usually for the amount of parts that we're making, it holds up well, and then when we're done, we can throw it away. And we always have that program from the router, so if we need to, if that job comes back, we can cut that fixture out in an hour or two and get rolling. We also make our own check fixtures, so rather than having an engineer with calipers and a tape measure out in the factory measuring something for 10 minutes, we can make a check fixture for them to check it in 1 minute. And if it doesn't fit in that fixture, then we can probe in and figure out what went wrong. So it's all about trying to get faster without sacrificing any quality. Something that we didn't initially expect was actually we have customers come to us asking for check fixtures for their plant. So it's a lot cheaper to buy check fixtures and make sure it's right before you install it in the car rather than doing rework. So sheet metal fabrication, you see sheet metal everywhere you go. It's a very big industry, and a lot of what we'll tend to do are fuel pumps, housings for fuel pumps, and enclosures. Like all of your computers have enclosures and housings. And some of the examples of what we've gotten to do, this here, as I alluded to, is a enclosure for an industrial type fuel pump. It holds the hoses and all of the equipment inside, and there's also a mounting bracket for an LCD screen and everything like that. So also the one in the top center there, I believe you have these in some of the computer labs here, but all the wires run up from the floor rather than having them run through the room. This is the housing that goes in the floor, and it holds all of the power plug-ins and the Ethernet cables and everything. They interface through here, and there's a plastic lid that goes on top that flips open so you can see it. And then in the bottom center, we actually had a customer come to us, and they said, I have a tablet. They were a delivery type of company, and they wanted their drivers to use tablets to track where they're going. They could use GPS and track all the shipments. However, they were really concerned about people stealing the tablets, not employees, but they didn't want people to get in the truck while the employees were making a delivery. So we developed this box which locks the tablet inside, and it has all of the heating or ventilation to dissipate heat, ventilation holes, it's got a hole so they can still use the camera. It has mounting holes so they can mount it to an articulating arm in the dash of the car, and buttons to interface with all of the parts of the tablet. Oh, and by the way, you have 2 weeks to ship it to us. So it can be challenging at times because of the short production cycle, but at the same time it's very rewarding to, in a short amount of time, develop something like this and have a nice product at the end that actually works. Which also can be a big challenge is that usually a customer is coming to us and they expect it to be right the first time, every time. So it's like a new prototype, but you can't mess it up. If we do, then we fix it and we make it right, and we catch it during production before we get it to the customer. But It's like every single day we see something new, and we never know what we're going to come into. As far as machined products, these down here, they really don't look like much, but when you get into the tolerances that were involved in making these, it can be pretty difficult to program our mill and hold the tolerances. They're actual machine components that go into larger machines, such as the machines that make cardboard boxes. I think one of them is a motor mount and pulley mount for that type of a machine. And then over here on the right, I think Drew mentioned this one in his slide. It's an enclosure for laser sensing systems that actually track where trains are in the metro system and make sure they don't run into each other. And it basically protects their enclosure from the environment and all the dirt and grime in the tunnels. And you know, it has security screws and everything, so nobody can get in there and tamper with the system. So that was what you saw cutting on the mill. I know there was a lot of coolant, so you couldn't really see much, but it was rotating and cutting all of these pockets out, and there's brackets and everything inside to hold the laser within the housing. So as I was getting into in the beginning, we get sort of a cradle-to-grave experience as an engineer at Marlin, which means you have to be a bit of a jack-of-all-trades. You know, you have your design aspect from the front end, and during your design, we have to take into account, I'm not sure how many classes you've taken, but I'm sure you've all heard of DFA, DFM, DFX. Well, I didn't think that much about it when I was a student, but now that I'm actually designing products, I realize how important it really is. And it could be things as simple as making tabs so that we don't have to build a fixture on a sheet metal assembly, so that when we don't have to build a fixture anymore to assemble it, they can just click it together and then weld it in place, and it's going to be in tolerance with the way we've designed it. Or another really big one is designing parts so that it doesn't matter which way they flip it, it'll be right, or so that they can't put it in, assemble something in the wrong orientation. Sometimes we have to do tooling design if customers are demanding something of us that our current tooling can't do, then we have to make tools to do it. We have the machines in our factory to make our own tools, so sometimes we have to do that because our vendors for tooling may not be as fast as we need them to be. So we'll design and make our own. Also, part of the design process, as Drew mentioned, was stress analysis. We're getting more and more customers that really want to have confidence in how much they can put in their basket. And they need it to adhere to certain ASTM standards. So we have to do our stress analysis on the front end to make sure we design it right. So then, and then when it gets built, we also have to do our load testing before we can ship it to the customer. That way they have 100% confidence that what we made for them is going to work and nobody's going to get hurt. As an engineer, we also get to do a lot of the programming for the machines in the factory. The biggest four are our 4-axis mill, the sheet metal punching machine, the laser, and the router. So some days when I'm tired of designing something, well, there's plenty of programming to be done, so I can switch over and program the machines in the factory. And it's really neat to design something and then also do the program for it, and then go out and you can see that program running in your factory, making what you've just designed. We also are all responsible for quality at Marlin, and the engineer's role in that is to oversee our ISO system, documenting all of our defects and taking care of customer concerns and complaints, and trying to get better every day. We also do the first article inspections, as I mentioned, and a percentage inspection, or we inspect a percentage of the final lot before it goes to the customer to make sure everything is as it should be. One of the reasons we really like to do that is because if we only had one engineer responsible for quality and they're out for a day, well, we can't have our whole quality system go down. So when we all cross-train, then it allows us to be flexible and react faster to the customer's needs. As you've heard, everything's about quality and quick. And so it can be stressful, but it's also rewarding at the same time. Work here at Marlin is a very fast-paced environment. As I mentioned, this enclosure, we had 2 weeks to make a custom design, build it, and ship it. And it had to work. So there was a bit of R&D involved at the front end of production where the first design or two didn't work, and then we had to fix it right away and then get new programs out to the factory so they could make the new design. As I've mentioned, we have the whole cradle-to-grave experience and, so to say, instant gratification, seeing what you've designed within a week or so, or a couple weeks. So the way we utilize CAD, we have Autodesk Inventor. We use a lot of their products. Also, all of the CAD models that we create go into our programming software, so we don't have any rework, so to say. We don't want to redraw something in Mastercam when we've already done it in Inventor. And also, the design that goes on our drawings is the exact same solid model that goes into our programming. That way there's no mistakes made there. Same software that we use for our router, laser, and punch. We pull the solid models or DXF files straight from AutoCAD into our programs. Courses that I either took or saw as valuable when I was an undergrad, obviously this is industry specific, but ENME 414, you're all here. It's really a valuable skill to have, and I'm sure once you get out there, you'll probably get to use it. Well, it depends on where you go, but I see a lot of engineers use it pretty frequently. ENME 470 for finite element analysis. We use it now, even before we had the Autodesk stress analysis package. That class still helped with visualizing and understanding how stresses work on complicated assemblies. So I think that's a very valuable class. Also, machine design. As I mentioned, we have to make our own tooling a lot of times, so that could be a valuable class to you. And production management. It's, basically it would help you with being able to improve processes in our factory or in your factory, wherever you wind up working. Some tips that I would say as far as using CAD. Yes?
Is each engineer responsible for several different jobs at one time, or do they usually have one specific job they work on per day? Or?
No, we're all working on different things and multiple projects. We're not necessarily given one project and that's Tony's project and he's going to do everything for it. We try to schedule the work so that you have some consistency with one engineer following it through the production process, because at the beginning in the design phase you have a little bit more insight into how everything should work, and that's valuable at the end when you're doing final inspection. But in any given day we're usually doing some design work, a little bit of programming, as well as drawing releases for the factory. It's all just, it depends on how many new jobs versus jobs going into the factory we have. Yep.
As you invest in this new technology, do you guys have a lot more machining to do as the engineers, or is are the people on the floor getting more training for it?
Usually we train some of the engineers as well as guys on the floor, because just because we wrote the program, we also need someone in the shop to be an operator. And also, if the engineers aren't available for some reason, the operators can also do some programming out in the factory at the podium of the machine. So we do train both engineers and the factory workers. Yes?
What made you guys choose Autodesk as opposed to software?
I wasn't part of the decision process. They had it when I started working there. And when I was going through this class during my undergrad, we didn't use Autodesk at all. We only learned Pro E and SolidWorks. So it was difficult to get in there and have a totally new system, although it's all pretty much the same. It's very easy to transition. If you can do SolidWorks, Inventor is very similar, as you've probably seen or will see. However, from going to several training courses with Autodesk and working with the Autodesk products for a few years, I think I prefer Autodesk. It's just the things that it does well, or it does a lot of things better than SolidWorks. SolidWorks has some features that Autodesk doesn't have, or Inventor doesn't have, I should say. But I think, in general, the Autodesk stuff works better, just in my preference.
I have got a question. 2 minutes leave for me. 1 minute leave for her. This is the thank you very much.